This is Daniel. Today, we will now solve question 1A on MAT 2008. The question asks find the stationary points on this curve. I bet when you have watched that many MAT videos or done as many MAT videos as me, this question will become no longer extraordinary to you. But if you are new to the series, let's try differentiating. The derivative of this curve is 6x squared minus 12x plus 5. Now, the question asks find the number of stationary points. What do? We find the discriminant, b squared minus 4ac. B is here, a is here, and c is here. So, b squared minus 4ac equals to 12 squared, actually negative 12 squared, minus 4 times 6 times 5 equals to 144 minus 120 equals to 24. And since b squared minus 4ac is positive, we have two stationary points. And one thing about cubics, all cubics have rotational symmetry. Got that fact sink in? Well, let me tell you that this cubic actually has two of what they are called points of inflection. And what are points of inflection? So it's basically when you have this gradient and then you have this maximum gradient and then it goes to 0. Basically your gradient goes from here. So this is your x-axis. Your gradient curve will become this and then this and then this. So that's where it has its minimum. Where it has its minimum is where the second derivative is 0 and bingo, that's your point of inflection. Now when we take the derivative and find the points where x equals 0, I mean the third derivative is 0, we won't know. Unless we go try it out with this curve. Since we already figured out dy over dx, let's find d squared y over dx squared equals to 12x minus 12 and d cubed y over dx cubed equals to 12. And I have no idea what this means to the curve, but what it tells us is that the gradient of the gradient of the gradient is constantly 12. Now, let that fact sink into your mathematical brains. And, what else shall we do in this polynomial? Find its roots? No way, we're never going to find its roots. Anyway, you've seen other cubics. You know that all cubics have rotational symmetry, which I've seen. In all cubics have rotational symmetry. All quadratics have reflectional symmetry. And let that fact sink in, and goodbye.